So we're going to spend a lot of time today graphing just a couple parabolas. Now, this is a little bit more challenging for this one because you've got a coefficient other than a 1, so there's going to be some extra work in doing some of the things we're going to do. The big, let me tell you the things that I want when you graph a parabola. I'm going to want you to find, first of all, the vertex, and then the y-intercepts. Those will be easy points to get. X-intercepts, those will be a little more challenging. And last but not least, the equation of the axis of symmetry. So those are the things I'm going to want you to find. But the big thing is finding the vertex, because you're not going to get very far in terms of graphing the parabola unless you can find the vertex first. So there's going to be a couple ways you can find the vertex. One is if you take your equation in the so-called standard form and put it in vertex form, then you'll be able to read off what that vertex is. So let me start out with this equation and work to put it in vertex form, I should say. So this is going to involve the process of completing the square. That's the stuff we did in section 10.1. I'm going to start by moving that 30 to the left-hand side, and that'll give me y minus 30 equals 2x squared minus 16x. And here's kind of the first little note that I put here. So you can go back and decipher things later. We want to factor out the leading coefficient of the x squared term. That's going to be the 2. Now, I know it's tempting to factor out a 2 and an x, because 2 and an x would be your GCF. We only want to factor out the 2. So that's going to leave me with a y minus 30 plus something equals 2 times something. Well, the question is, if I factored out a 2 from both of these terms, what's left behind?
X squared 8x.
X squared minus 8x. And let me put a little plus something in here, because this is that number to be named later. So what we want to do is we want to complete the square inside the parentheses. That's why I factored out the 2, because our process of completing the square requires that we have an x squared term by itself, not a 2x squared term. So complete the square. Do you remember how that goes? What do I do to complete the square? I'm just working with what's inside the parentheses. Go on. Yeah, 1/2 of the b term is -4, and then -4 squared is 16. So that's 16 is going to go right there. So let's put that 16 there. So 1/6. So I put 16 here, but if I put something on the right-hand side, I also going to put something on the left-hand side to keep things in balance. What would I put here to keep this in balance? And I'll give you a hint, it's not a 16.
-16.
So if you think about it, if I distributed the 2, I'd get 2x squared minus 16x, which is what I have here.
-32. Plus.
But when you distribute the 2 here, 2 times 16 is really 32. So by putting a 16 here, I've really added 32 to the right-hand side. So to keep things in balance, I'm going to add 32 to the left-hand side. Okay. Now the left-hand side, I can combine these. That's going to be y plus 2. On the right-hand side, somebody actually mentioned the right number that I need here in the middle. The right-hand side, this term factors. This is a perfect square. That's why we completed the square, so I could write that as something squared. X minus 4. Good. Remember, when you complete the square in this fashion, you end up using both of those numbers. First one here, this one here. So, good. Now, let's move the 2 back to the other side. So, you can come back over here so that we have y by itself. And I'll have y squared, or y equals 2 times x minus 4 squared minus 2. And this is the vertex formula that I was looking for. I wanted it in this form because I claim it's really nice to work with. You can just look at this and read off what the vertex is. So, start by making the squared term equal to 0. Vertex. What makes the squared term equal to 0? What does it do? What does it work out to be in this case?
4.
All right, a 4. Now, if I put in a 4 here, Sarah, maybe you can help me out. If I put in a 4 for x, what would I get for y? Yeah. So the 4 goes in there, and when I do 4 minus 4, I get 0. 0 squared is still 0, times 2 is still 0. 0 minus 2, well, hey, that minus 2, that's the y-coordinate of my vertex. So when you've got it in this form, you can literally read off the vertex. It's going to be that number and this number. Here, you got to kind of change the sign on that term. All right, I get it. But more or less, you can read it straight off. So, great. We've got 2 different forms of this parabola. You've got y equals 2x squared minus 16x plus 30. Or you can write it as y equals 2 times x minus 4 squared minus 2. So which one's better? Well, they're both good at doing different things. So this one's your standard form. This one's your vertex form. And at least we got the vertex for this, so that's a good start. X and y. So the vertex is 4, negative 2. How do I find the y-intercept? Does anyone remember that? How do I find the y-intercept? Nick?
Set x 0.
All right. Sterling?
Set x 0.
Yeah, thanks. And I think Carvel, you said that as well. Thanks, gentlemen. Set x equal to 0. So if I set x equal to 0, now I've got my choice of either equation, but which equation does look easier to use? If you're going to set x equals 0, you can use the first one or the second one?
Second.
I like the first one. Because what happens when you put a 0 here? A 0. And then what happens when you put in the 0 here? So when you set y equal or set x equal to 0, then that's your vertex. That's your y-intercept, I should say, not vertex. So 0 and 30. Now you'd get the same thing eventually here. It'd just be a little bit more work, but that's okay. How are we going to find the x-intercepts?
Set y to 0.
Set y equal to 0. And let's take a look at what that's going to entail for these 2 different problems. So for our standard and for our vertex. For our standard form of the equation, then that's going to look like this. 0 equals 2x squared minus 16x plus 30. You've got a lot of variety as to how you might want to solve this. What would you choose? How would you solve that? You'd subtract?
No. I
heard quadratic formula, factor, all right? If you're going to factor, what would you do to factor?
Factor out the 2.
Yeah, let's get rid of that 2 here. So there's a greatest common factor of a 2. Let's factor that out. So if I factor out the 2, what's left behind?
X squared.
X squared.
Plus 15.
You're factoring out a 2. 16 divided by 2 is 8 plus 15. All right, that looks good. Now, let's see if we can't factor out a little bit more. Now that we got rid of that 2 out in front, I mean, we'll leave it there. It's not going to hurt anything. But how does this factor? Brian, C? I'm sorry, I think Pro was also saying that.
Is it x minus 5, x minus 8?
So you want two numbers that multiply to positive 15 and add to negative 8. So they both have to be negative, so that a negative times a negative gives you a positive. And then, thank you, 3 and 5. All right. So now you got something times something times something equals 0. One of these somethings has to be 0. Because when you have a product of things equal 0, there has to be a 0 someplace. Now, can 2 equal 0? No. But x minus 3 could equal 0, or x minus 5 could equal 0. And I hope that in your own work, you just jump down to, 3 and 5. Great. Done. That's what the work looks like using standard form. You could have also solved it this way using the quadratic formula. I hope that if something factors, that you factor it instead of using the quadratic formula, because the quadratic formula is just tedious. There's just no other way around it. Let's take a look at what this is going to be if we were to use the vertex form. How's that work going to look different? Well, so for the vertex form, I'm going to take this, I'm going to plug in y equals 0. So I'll get 0 equals 2 times x minus 4 squared minus 2. Work me through this. I don't want to use the quadratic formula here. I don't want to factor here. I want to take advantage of the fact that I've got a nice squared term here. What could I do? Lauren? How would I get the squared term by itself? Would be a good first step. Well, I want to get the squared term by itself, so I need to get rid of a few things.
So would you do x minus 4, x minus 1?
That's not the way I want to go with this one. I want to keep that squared term kind of intact.
To both sides and then divide by 2.
All right, so we'll add 2 to both sides. I get 2 equals 2 times x minus 4 squared. And was that Nick? Divide both sides by 2. If I take this and divide everything by 2, let's see here. We'll use orange for some variety here. Then, this is looking a little bit better. I get 1 equals x minus 4 squared. Great. Thanks, Nick. This is not a bad place to be. How can I solve from here? What would you suggest I do?
Right, x minus 4 and then x minus 4.
You could. That'd be kind of a little bit more work if you were to multiply this out. So the fact that I get a nice squared term here is just calling out to me. It's like, just do this.
Square root.
Square root. So square root of 1, square root of x minus 4 squared. Ryan G, what am I missing from this? What did I accidentally leave out when I wrote this?
Sorry, I don't know. I just,
Some help?
I just got here.
Yeah, the plus or minus. Yeah, you got to get that plus or minus. There's two solutions. If we don't do that plus or minus, we're only going to get one of them.
Oh, it's not after the equal sign?
No, no.
Oh.
I want the plus or minus with my constant, not over here. What do I get over here?
X minus
Just x minus 4. So I get x minus 4 equals, well, I really hope that you simplify the square root of 1. I mean, even if my favorite football team wins, I get really unhappy when people leave it as a square root of 1. I hope you can simplify the square root of 1. There's two possibilities here. One positive, one negative. The positive one is 1 equals x minus 4, or negative 1 equals x minus 4. Notice you're just changing up on what sign you use here, positive and negative. Both of these are going to solve pretty nicely. Just add 4 to both sides. But what you can't do is just go, oh, plus or minus 3 or something like that. When you actually do take the time to solve it, you get 3 and 5. So, yay. Get the same thing that we got originally, 3 and 5. So that goes along with y equals 0, and that's going to be our x-intercepts. So let's put those back where they belong, up here. Y equals 0, x is 3, or x is 5. And those come from right down there in the blue. Great. These are the 5 points that I wanted. And I don't think I've got an extra copy of the handout from the other day, so we'll have to do this one by hand. We're going to want to graph these points. So let's just give ourselves a decent axis to work with. And, let's see. Probably this should work good. So 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So I'll label that negative 2, 2, and 4. This will be negative 5, 5, 10, 15, 20, 25, and 30. That should be pretty good. Let's see if we can't plot all our points. We'll start with the vertex at 4, negative 2. You know what? I'm going to need a little more space here, aren't I? Yeah, probably. Yep. 5, 6, 7, 8. Perfect. So 4, negative 2 is going to be down around here someplace. You know, not sure exactly where I want to draw it, so let me just put it about here. 4, negative 2. Then we had points at 5 and 0, which is here, and 3 and 0, which is here, and finally way up here at 0 and 30. There is actually one point you can get for free out of all this, and that's because the graph of a parabola is symmetric. I mean, you see it here. Here's the vertex, and right through here this line is the axis of symmetry. That's going to be x equal 4. If you move one to the left, oh, we've got an x-intercept. If you move one to the right, you've got another x-intercept. There's a point way up here at 0 and 30. Can anyone tell me where the symmetric point would be at?
Maybe 8 and 30?
Yeah, 8 and 30. Beautiful. I like seeing these symmetric points. They help you draw things, and you know, sometimes they're going to give you an extra credit point. So let's play connect the dots. What I'm mostly looking for is a nice smooth graph. You know, it might not be perfect, and this is an example of something that's certainly not perfect, but as long as it doesn't look like the absolute value, that is have a really sharp point here, and it passes through everything else that it's supposed to, you should be in good shape. Make sure that when you give me the equation of the axis of symmetry that you give me x equals whatever number that is that goes through the vertex. Don't just give me 4. But other than that, there you go. So there's a couple ways to approach this. It kind of depends on what form of the equation you're given. Are you given the equation in standard form, or are you given it in vertex form? Okay. Now, one of the problems I want you to be able to solve is putting this into vertex form. Ideally, you should be able to complete the square like we did back here. I mean, that's ideal, but you know, not everyone's really that good at that. So if you're not good at completing the square, then what else can you do? Well, let's double check things on our graphing calculator first. So take out your graphing calculator. And while you're doing that, let me notice for us a couple things here. That is, as far right as this graph we need, that's going to be our x max. And as far to the left as this goes, that's going to be your x min. So this is setting up the window for your graph. Now, how far down do we need to go? Well, on the y-axis, that's going to be your y min. Y min, we're going to go down to -5. What do you think x max is? How far am I going to draw this graph out to the right?
30.
On the x-axis, that'd be 8, and then -2 for the min. On the y-axis, well, you know, maybe a little bit past the 30 here, so maybe y max would be 35. That'd be a good way to do my y max. And if you're graphing this for WebAssign and they give you a blank graph, you can just do what I did here, and that is kind of copy or mimic the x min, x max, y min, y max for all your settings. Start by pressing the y equals key. That'll take you to the equation editor, and we're going to plug in our equation. If there's something here, hit the clear button on the right, kind of a little bit below the down arrow, a little below and to the right, clear it all out. And let's type in 2x, which is next to your alpha key, 2x squared minus 16x plus 30, and then press enter. Great. Now we need to set up our window, because the graphing calculator is just going to graph it to whatever the window is set. And right now your windows are probably set to something a little bit different than what we want. So for x min, we want to go -2. Use the opposite key on the bottom row of your calculator, not the subtraction key on the right-hand side when you plug that in. -2 to 8 will work out pretty good. And then on the y-axis, let's go from -5 up to 35. And with those settings, you should get a pretty good looking graph of what we've got. So one last look at these settings. When you're ready, hit the graph key. And bam, looks like that. Pretty good. Now, there is something a little bit bothersome that is on the y-axis. This looks a little bit busy here, doesn't it? Yeah. So let's clean that up a little bit. What's going on here is that every unit, every tick, it's showing me a tick mark. And if you look at our graph, how far apart are my tick marks?
Very.
They're spaced 5 apart. So if we go back to our windows and then let's set Y scale to 5, now we'll get a cleaner looking graph. All right, it's not as busy. And in fact, on the x-axis, if you'd like to, you can go down and set Y scale equal to 2 and make it even a little bit more clean. Just realize that each tick mark is a unit of 2 now. All right, for those of you who've taken the time to follow me along with the graphic calculator, here's a little reward for you. Hit the trace key. That puts a cursor on your graph. You can kind of trace around. You see, for instance, that 3 and 0 is a point on your graph. You can kind of trace around and say, oh, wow. Looks like there's a point at someplace near 4 and -2. That's kind of cool. But you don't even have to guess at this. You can kind of confirm that, yeah, there's a point at 4 and -2 by just typing in the x value that you want. What's the x value of our vertex?
4.
4. If you press 4, a little window opens up at the bottom, says, do you want 4? And then you say, yeah. So you press enter, and bam, it puts a point on the graph there. 4 -2. Guess what? That's your vertex. That's pretty nice. So how could we use that to help ourselves out? Well, let me look here. We started out with something in standard form. Y equals ax squared plus bx plus c. And then we wanted to convert it to vertex form. Y equals a times x minus h squared plus k. All right. There's one thing I want to notice for you here, and that is that a is the same regardless. So whatever's the coefficient of my squared term here is going to be the coefficient of my squared term here. As far as h and k are concerned, h and k are the coordinates of the vertex. So let's look back at our equation. Y equals a, excuse me, not a, how about a 2? 2 times x squared minus 16x plus 30. If I can look at my graph and figure out that the equation, excuse me, that the coordinates of the vertex are 4, -2, that's my h, that's my k. How would you then rewrite this? Well, what's the a that goes out in front here?
2.
Yeah, that's the 2. So a 2 times x minus 4 squared plus k, which is -2. And you could write that as x minus 4 squared minus 2. So wow. If you're good with your graphing calculator, you can get this a lot faster than completing the square. Certainly a question that I will ask on an exam is to go from here to here. Start out with this form and right here. If you can do it by finding the vertex, you're a lot better off, I think. Now, as an instructor, I'd like you to be able to complete the square, like we did here. In fact, that is kind of a skill you're going to need because you're not always going to be able to graph these things and do this. But if I ask you on a test to start out with something like this and write it like this, if you want to use the graph and complete the square that way, well, it's not really completely square, but put it in that form that way, that's fine. Nothing wrong with that at all. Okay, comments or thoughts on that one? There's a little bit more we can do with this one. Suppose you don't have a good graphing calculator or you're just not comfortable moving around on this stuff. Let's take a look at this another way. Let's go back, and I'll call this method 2. Y equals 2x squared minus 16x plus 30. So there's another way to find the vertex, and that's going to be this way. X equals negative b over 2 times a. What's that going to look like for this particular equation? What's a?
2.
B is negative 16. So double negative gives me a positive. 16 over 4 gives me 4. That's the x-coordinate of my vertex, right? So I'm looking for x and y. So that's my x. Great. But how am I going to find the y-coordinate of the vertex? Sarah, any suggestions?
Sorry, I was. I would put it, we're looking at the
Factoring might be a little bit harder than you need to work at. How am I going to find the y-coordinate of the vertex?
You plug 4 in for x.
Yeah. Thanks, Pearl. Plug 4 in for x. So if I plug in that 4, that's going to be 32 minus 64 is negative 32. Negative 32 plus 30 is negative 2. And that's the y-coordinate of my vertex. Great. So once you have those two, then once again, you can put it in the form of y equals 2 times x minus 4 squared plus negative 2. So, you know, once you have the vertex, it's pretty easy to put it into this form. And then you can use this form or not to find, say, the x-intercepts. It's up to you. But you've got a lot of choices here that you can do. Just pick something that works good for you. By the way, just kind of a quick little mention here. Let's see, where's, gotta find, you can double check things by graphing it. You can check that you put it in the right form, 2x squared minus 16x plus 30. There's one graph. And here's the other one, y equals 2 times x minus 4 squared minus 2. And what should happen is that when you graph these things, one of them should land right on top of the other one. So here's your red graph, here's your blue graph. They're identical. So it's a way to double check it. You can do the same thing on the graphing calculator. You can graph both equations and make sure that they line up. All right, so lots of ways to look at these types of problems, graphing these. But the reason I'm spending a lot of extra time on this is because these are kind of big problems on the exam. They're like 12-point problems, 2 points for the vertex, a point for the y-intercept, 4 points for the x-intercepts, and 2 points for the equation of the axis of symmetry. And there's also a graph that you should be drawing as well. That's another 3 points. So there's a lot of points that go into this, and I hope that you know what I expect. We're going to practice this again, maybe go a little bit faster on some of the details. But before I do, how are we looking on the first one? All right, let's try another one. This one's going to work out a little bit different. It's not going to work out as nice and neat in terms of the x-intercepts. So I'm going to just tack this one on to the stuff that we had on our handout the other day. I'll call example G. F of x equals 3x squared minus 12x plus 5. And it'd be nice if I could write it in this form. Y equals a times x minus h squared plus k. Because then I could just look at it and determine what the vertex is. Or maybe I can look at the graph and determine the vertex and then put it in this form. So let's see about that. So let's look at the graph of this and see if we can't figure out what the vertex is. That means we're going to need to change our equation here on our graphing calculator. Now I have 3x squared minus 12x plus 5. And I'm not sure if you're used to using it, but there's a delete key up here. We can get rid of that. So there's my equation. Great. Problem is I don't know where to look at it in terms of the graph. My settings from the last window may or may not work. If you hit the graph key, well, looks like our graph missed a little bit. So what I could do is, well, you tell me, what more would you want to see out of this graph?
Negatives, Y's.
Yeah, it'd be nice to see it a little bit lower on the y-axis. So let's go down to say maybe negative 10. Cool. So as far as the vertex is going, anyone want to guess what the vertex would be in terms of the x's? Keep in mind that each coordinate is, or each tick mark is worth 2. So going back to our graph. Looks like a 2.
Yeah.
Hit the trace key.
-7, 2.
Hit the trace key and you'll see that you get x is 2, y is -7. That's our vertex. So let's write down from the graph. The vertex is at 2, -7. So that's your H and K. And see if you can't put that into the right form. So if you're watching this at home, pause the video. But see if you can't put this equation into this form now that we know what H and K are.
There's only an arrow to window range. You get it in the bigger than your X max. So we go from -2 to 8x. Y min. Equation.
Yeah, correct, A line.
Yeah, it's, well, that was part of the problem. The other part was that the window range, your Y min, or your X min is bigger than your X max. Yeah. Okay, so what's A? Oh, okay, all right, that's fine. So H is X minus H, so just 2 plus -7. So our A in all this is going to be 3, right? So it's going to be 3 times X minus H squared plus K. H in this case is 2. K is -7. And I'd probably be happier to see this as 3 times X minus 2 squared minus 7. Although I'm not going to mark you wrong if you write it like this plus a -7. It's still the same, you know, no big deal. So that's my f of x. So we've got 2 different equivalent forms now to use that we can finish graphing this with. Let's see. Let's do ourselves a little t-table here, x and y. 2 and -7, that's our vertex. Let's be clever about finding the y-intercept. So we're going to set x equal to 0 to find the y-intercept. You've got 2 different forms that you can use for this. You can use this one A or this one B. Where's going to be easier to set x equal to 0? A all day, right? In fact, you can read off the y-intercept when you set x equal to 0. What is our y-intercept? 5. So 0 and 5. But the x-intercepts are going to be a little bit more work. So for the x-intercepts, you're going to set y equal to 0. And that's going to give us our x-intercepts. So 0 and 0. And again, you've got 2 different forms of the equation that you can do this for. You can do it with the standard form, that'd be this, or you could do it with the vertex form, which would be this. If I had the vertex form, this is what I would do. So set y equals 0. 0 equals 3 times x minus 2 squared minus 7. Jameson, work us through this. What would you do to get the squared term by itself?
Add 7 and then divide by 3.
All right, add 7, divide by 3. Great. Then what?
Square both sides.
Square root.
Square root both sides.
Square root both sides, good. So we'll take the square root on both sides. What did I forget?
Plus or minus. Plus or minus.
Yeah, I need that plus or minus there. Plus or minus. So, all right, that's going to be plus or minus square root of 7/3, which is x minus 2. Are 2 and the square root of 7/3, are those like terms? Can I add those up? No, not really. So what I'll do is I'll write this as, let's see, when the 2 comes over to the other side, it comes over as a positive 2, changes sides, changes signs. So I get 2 plus or minus square root of 7/3. When you list it in WebAssign, you're going to have to just write them out one at a time. 2 plus the square root of 7/3 and 2 minus the square root of 7/3. That's what you're going to have to list it in as WebAssign. But let me show you can check this on your graphing calculator or on Desmos just as easily. Are we okay with this part? If you wanted to, you could solve this with the quadratic formula, but you wouldn't use part B to solve it with the quadratic formula. You use part A to solve it with the quadratic formula. I'll put a copy of this in the notes, but here's what it would look like if you use the quadratic formula to solve here. So you plug in all these numbers, you simplify it. Square root of 84 simplifies into 4 square roots of 21. So now you got a 2 here. You've got a couple choices. The easiest choice, and I got to admit as an instructor I'm not really happy with this, but it's probably easiest for you, is to split this up. Divide each term in the numerator by that term in the denominator, and then simplify it from here down to here. So 12 over 6 gives you your 2. The 2 cancels there. You're left with 2 plus or minus the square root of 21 over 3. Square root of 21 over 3 is what you would get if you rationalized this number. So it's the same thing. Like I said, I'll put a copy of that in the notes if you want it. You can check these on your calculator. It might not work out perfectly, but it'll work out pretty good. Let's see. So if I wanted to check that, I would hit the trace key, and I want to trace and type in that number, 2 plus the square root of 7/3. When you hit the 2 or any number, it's going to open up that key on the bottom, or that row on the bottom for you. 2 plus the square root of 7 divided by 3. And there you go. Oh, worked out perfect. Sometimes you get something which is in scientific notation really close to 0, but this time we got it. It worked out perfect. 3.527, etc., and then y equals 0. It's exactly what we're supposed to get. What's the equation of our axis of symmetry?
X equals.
Yeah, perfect. Axis of symmetry. X equal 2. All right, so a lot of ways you can work on these things. It's up to you to bring together enough of this information so that you can get all 5 of those things that I'm looking for. And as a reminder, that's these 4, and then the 5th part of this would be to graph it. And here, one of the things I look for when I look at your graph is, does your graph match what you actually came up with in terms of coordinates? So to finish this one off, this would be 2 plus the square root of 7/3 and 2 minus the square root of 7/3, along with 0. Now, if you're graphing this by hand, maybe you want to try and figure out what that is numerically, get an approximate value. But That's no more difficult than just typing it into your calculator like I did here. And here's one of them, 3.53, we'll call it. 3.53. And then you can get the other one as well. You can do 2 minus the square root of 7 divided by 3, about 0.47. Yeah, I gotta correct a little typo here real quick. So this is about 0.47. The only reason I'm putting in these approximates is because when you graph this by hand, you're not going to graph it, you know, more accurate than the nearest hundredth. Even the nearest hundredth is probably overstating it. As long as it looks close to the nearest tenth, I'm fine. Okay, let's put this one to rest. Comments or thoughts before I do?